All right, we are back. We are now going to determine how to write our exponential equation from a graph. So I'm going to use a table to find points from my graph and then do the same steps we did previously with the table in order to find the equation. So first I need to find nice, pretty points on my graph. I want to find them that are perfectly at the crosshairs of x and y values. I don't want to use any fractions or decimals if I don't have to, because I would have to estimate what they would be. I do see that I have my y-intercept at 0, 1. So that's going to be a point that we use. And going to the left of that, I see a point here at -1, 2, and another point at -2, 4. And continuing up, we find more. I don't see any to the right of that y-intercept. Since this is a decay, our graph is going to get closer and closer to 0 on the right-hand side of the y-intercept. So I'm not going to use any of those decimal type numbers because I would just be estimating where they are. So I'm going to put in my table -2, 4, -1, 2, and 0, 1. So from here, I am going to slide over to my workspace. And the first thing I want to find is A. A is going to be that y-intercept. And so that is going to be 1. And then I need to determine what the value of B is, which is going to be the rate of change for the y values. So going from 4 to 2, what am I multiplying by? Going from 2 to 1, what am I multiplying by? I can find this by taking the previous y. I'm going to take 2 and divide it by the y before it, 4. And that gives me 1/2, or 0.5. So they are being multiplied by 1/2. You can use 0.5. It does not matter to me. So for our equation, we have 1 for a, parentheses, 1/2 exponent of x. The 1 in front of the parentheses doesn't really do anything, so you can also just say y equals 1/2 exponent of x. So either of those work as okay versions. All right. So we're going to look at example 3 here. Same idea. I'm going to find points on my graph that are at nice neat crosshairs. I see my y-intercept here at 0, 1. And then continuing up, I have another at 1, 2. Then another at 2, 4. And on upwards. I really only need 2 points, but sometimes I like to have 3 just to make sure the numbers are working out correctly and showing that this is actually exponential. So my y-intercept, my a is at 1. And then looking at the values for b, 1 times what is equal to 2, 2 times what is equal to 4. Well, that would be 2 each time. So b is going to be 2. So my equation is going to say y equals 1, parentheses 2, exponent of x, or again, that 1 doesn't do anything, so we could say y equals 2 parentheses, or 2 exponent of x. So this is very similar to the previous example. Instead of it being 1/2, it's just 2. Okay, and our last example here, I'm looking at my graph and I see a point here at 0, 2. That is going to be my y-intercept, and my value for a will be 2. And then continuing, I only have one additional point, and that's at 1, 2, 3, 4, 5, 6, 1, 6. So here I only have 2 points to work with. Again, we found our y-intercept, which is a, which is 2. And so going from 2 to 6, I'm multiplying by 3. So b is 3. So our equation says y equals 2, parentheses 3, exponent of x.